Okay, so Hess's law is yet another way to calculate the energy or enthalpy in a reaction. So Hess's law basically says that the enthalpy change during a reaction depends only on the reactants and the products, and it really doesn't matter how you get there. So basically, if you know enthalpies of different reactions, and then you can take two or three different equations and actually put them together to get the thing that you want, if you can do that, you can figure out the enthalpy of that reaction that you want. So when you are calculating the enthalpy change with this, you're basically going to be given three or four different equations or reactions, and you can manipulate them. You can flip it, you can multiply or divide it, and basically what you're trying to do is get one ultimate equation. So everything that's not in the equation that you want, that's not in it, you want to get rid of it. And you want to make sure that your reactants are on the correct side, your products are on the correct side, and you're going to do this by taking a series of reactions and just manipulating them. And then at the end, whatever you do to the enthalpy or the equation, you're going to do to the enthalpy, and then you're just going to combine them. So for this problem, I want to get the enthalpy change for this reaction. Carbon plus hydrogen produces C2H2. I want to know how much energy is involved in this reaction. Well, I was given three different reactions, and I was given the enthalpies of those. So what I'm going to do is I'm going to take this equation, and this equation, and combine it to get this one. So I can flip it, I can divide it, I can multiply it. Whatever I do to the equation is what I do to the enthalpy. And then at the end, I just get the sum to get the enthalpy of what I want. So let's write out the reaction that I want. I want to get 2C plus H2 produces C2H2. So here are the three reactions I do know the enthalpy for. So basically what I do with this is I focus on what I'm given in the reaction. So I'm going to focus on where I see the C, where I see the H2, where I see the C2H2. That's what I'm going to do first. So whatever you do to the equation, you're going to manipulate this. That's the end goal. That's how you're going to get what you actually want, which is delta H. So you're going to combine these three reactions to get carbon plus H2 equals this. So this is a product right here. So that means that it needs to be a product in one of these equations. This is the only equation that involves C2H2. But on this one, it is a reactant. So I need to actually flip this equation so I can get C2H2 on the correct side. So I'm going to do that first. And I also have 1 mole here, 1 mole here. So I don't need to multiply it or divide it, but I do need to flip this. So when I flip it, I'm going to get 2 CO2s. So products become reactants, and reactants become products. Okay. So I flipped it here. So what this ultimately means is that with this, I'm going to flip this. So if I flipped it, I'm going to reverse the sign. It's negative here, so I'm going to make it positive now. All right, so now let's focus on the carbon. So carbon is also involved in just one reaction here. So it's right here, and it's on the correct side. It's a reactant here, it's a reactant here. But I don't have the correct number. So I'm going to multiply this entire reaction by 2 because I need to have 2 carbons in my reaction. So I'm going to multiply everything by 2. So this gets multiplied by 2, this gets multiplied by 2, and then this gets multiplied by 2. So if I do that, all my coefficients will change to 2. So 2 times 1, 2 times 1, and 2 times 1. But what this ultimately means, though, is that this has to get multiplied by 2 because I multiplied the reaction by 2. All right, so now I need to look at my H2. Well, H2 right here, it's a reactant, so I don't have to do that. I don't have to flip it. And also, it happens to be 1 and 1. So I probably don't even need to do anything to this reaction. But what I do need to do is I need to see if I combine these three reactions, I get this. So basically, if something appears on the reactant side of one equation and the product side of another, that means they will cancel. If they appear on the same side, you have to combine them together. So let's see what we can cancel. I've got CO2 here, and that's a reactant, and then CO2 here, so that's a product. And they've got the same amount, so they will end up canceling each other. They have to be on opposite sides to cancel. All right, so now we need to look at H2O. I've got H2O here, and then H2O here, so that will cancel. All right, so now I'm left with this. This isn't anywhere to cancel, but I don't want to cancel it. I want it in the reaction. And this is also not going to cancel, but that's good because I want it. H2 is also not going to cancel. So now we need to look at O2s. I've got 5 halves on this side, and then here I've got 2 and then another half. Well, if it's on the same side, you combine them. So 2 plus 1 half will actually give me 5 halves. So I do have 5 halves on the reactant side and the product side. It's just since they're in 2 different reactions and they're on the both on the same side, they will be added together. So that will cancel, and that will cancel. And what I'm left with is this. Which is what I wanted. So the whole point of doing this is not to do this to get this reaction, but to figure out what you're doing to the enthalpies. So I flipped this one so it became positive. And then I'm going to add it to all of my other enthalpies. So plus 2 times negative 393. Plus, I didn't do anything to this one, so just negative 285. And then just add them together. And then when I do that, I'm going to get positive 226.7 kilojoules per mole. All right, so whenever we're doing this, you're going to manipulate the equations to get your ultimate equation that you want. Whatever you do to the equation must be done to the enthalpy, and then at the end you just combine the enthalpies. So let's look at another one. All right. Okay, so let's look at this one. I want to find the enthalpy change and this equation right here. And I was given these 3 equations, so we're going to do the same exact thing. Okay, so this is the equation I want. All right, so these are the 3 equations I'm going to manipulate to get this one. So again, I like to focus on what is actually in the equation first. So for the first one, okay, if I'm looking at CO2, here's CO2, and it's not in any of the other equations, so it's on the wrong side. So I'm going to have to flip this one to get CO2 as a product. So that's what I'm going to do. So products become reactants. So SrCO3 becomes a reactant, and then I have SrO plus CO2. All right, so I flipped this, which means that this sign needs to change to positive. All right, so now let's look at the next one. Okay, I've got O2, but I've got O2 over here, so I'm going to look at the other equations first. So when I look at this one, I've got carbon. Okay, carbon is only found in one reaction, this one. So that means that carbon needs to be on the opposite side. So I need to flip this, and also it looks like I'm going to want to divide this by 2 so I can just get 1 carbon. So I'm going to flip it first, and I'm going to divide it by 2. Divide everything by 2. So I'm going to flip and then divide everything by 2. So that this means this becomes negative here, and I'm going to divide it by 2. So I have SR, 2SR plus 2C plus 3O2 produces this, but I need to also divide it by 2. So 2 divided by 2 would just be 1. 2 divided by 2 would just be 1. 3 divided by 2 would actually give me 3 halves. And 2 divided by 2 would also just give me 1. Okay, so I flipped it, so I changed the sign, and I also divided that by 2. All right, so now let's look at the next equation. Let's look at the second one. All right, so now we have to figure out what we're going to do about these O2s. And also, I need to make sure everything cancels. Well, I could focus on the O2s, or I could also look at the other substances that I have in the reaction. So if I look at this one, SRO is not in the ultimate reaction that I want. So I need to get rid of it. But right here, it's on the correct side. I've got a product and then a reactant, so they will cancel, but not all of them. So I need to get rid of some of these SROs. So I need to divide this by 2. So if we do that, so if I divide this by 2, that's going to give me 1, 2 there. It's going to give me 1 SR here, and then a half an O2 here. So I'm going to divide this one by 2. Well, let's see if everything cancels now. All right, so strontium carbonate. Well, it's on reactant side and product side, so that's going to go away. SRO, strontium oxide, well, product, reactant, it'll go away. And then strontium is a product here, reactant here, that'll go away. All right, CO2 will not go away, which is good. I don't want it to. Carbon will also not go away. Now I need to figure out what to do about these oxygens. Well, I've got half an O2 here and 3 halves here. Well, the smaller one will cancel. They're on opposite sides, so that one will cancel. But I also need to cancel out another half an O2 here. And sometimes people have a hard time seeing what to do with the fractions. So you could look at it this way. It's 0.5, and this is 1.5. So if this is going to go away, then a half will also go away here. So it's just going to be 1 O2 at the end. So this 3 halves becomes 1 O2. All right, so now we can combine it. We've got carbon, 1 oxygen, because the half an oxygen canceled here, and then CO2. So I've got exactly what I wanted. Now I just need to take my enthalpies and combine them together. So I've got 234 here, positive because I had to flip this one, and then 1184 divided by 2 plus negative I wrote that down wrong again. Okay. This is not 2,240. This is actually negative 2440. All right, so 2440 divided by 2. So you take all of these, combine them together, and you should get negative. Actually, let's do that really quick. 234. Okay, should get negative 394 kilojoules here. All right, and that concludes that one.